Hello and welcome to today's video. We're going to talk about set operations. This is kind of another one of the important topics here. I feel like I'm saying that every video, but really this class really builds on itself in many ways. So it's really important that you understand these fundamentals because they're going to be applied later on. And the one we're going to talk about here is set operations. So lucky thing with this, there's going to be a lot of drawing of Venn diagrams today. This is nothing too complicated. These are just rules you need to know. So each and every subset A is in some universe U. So I like to write the universe as some big circle here. This is the universe. It could be all real numbers. It could be something like that. And then we have somewhere in this, we have A. So A, no matter what A is going to be some subset of U, where U is this bigger universe. So A could be something like 1, 2, 3, and while N would be the natural numbers, if that's what we were talking about here. So no matter what it is, there's always going to be some larger set, and that's the universe U. Just kind of an important concept. Okay, so the complement of A, everything in the universe that is not inside of A. And it's notated, these are important here, it's notated by AC or A bar. So I'll write that bigger, AC or A with a bar on top of it. And what AC equals, it equals U minus everything in A. It's everything that's inside some universe that you're working in, but it's not in A. So again, we have the universe U. So U, and then we have A. I'll write A here. And now my answer for this is going to be everything that's in the universe, but not inside of A. So that's the complement. So everything except A. So that's all of that space there. And the way you write it in set building notation, you would say X, where X is not an element of A. So it'd be everything that's not in A. So complement, not too difficult. Intersection. This is an important symbol to know. So A, when I write that upside down U, read that as A and B. You're going to see that one again and again, so just know that that's A and B. And that's exactly what it sounds like. So now we're going to say that we have some circles here. We have A and B, and we're going to assume they're joined at some point. So this is set A, this is set B. If I'm looking for the intersection, remember in set building notation, we would say X, where X is an element of A, and X is an element of B. Well, if X is an element of A and B, that's got to be in here, right? Because that's the only spot that satisfies both of those requirements, where it's in A and it's in B. That's got to be right there, only place. All right. So now the union. So A union B, we read as A or B. If you see that symbol, read it out loud as A or B. So that's this symbol right here. That's kind of like the U basically. So A or B right there. And now this one is exactly what you'd expect. It's X, where X is an element of A, or X is an element of B. And this is important here because in the English language in general, if I say I want oranges or bananas, people wouldn't think that that means I want oranges and bananas. But in math and really just in the language in general, that's what it means. It's inclusive or. So I'll write that here. It's an inclusive or. So you can be both. It's not just one or the other. Okay, so now again we're going to be working with A, we're going to be working with B. We're going to assume they meet somewhere in the middle. They don't have to, but we're going to do that for our example. So I remember our condition in set building notation. We have X, where X is an element of A, or X is an element of B. So I'm going to first start with X as an element of A. That includes this intersection, right? And then it says or X is an element of B. Well, X as an element of B, there's going to be some overlap there. Those are my answers. It's the entire thing is A or B. And remember, just so you guys remember, we assume there's some big universe on the outside. So it doesn't mean that X or B is necessarily everything in the universe. We just mean it's everything in those two sets. And it's inclusive, so that means that this middle spot does count right here. So middle counts. So that means that A and B is inside of A or B. That's an important thing to know later on. All right. And lastly, we have the difference of A and B. So that's kind of what you would expect. So if I have, again, I have my A and I have my B, and they meet somewhere in the middle. And you just write this as A minus B. There's nothing special really for notation here. This one you don't see as much, but it's still a good one to know. And this is, like we say in set building notation, X, where X is an element of A, and X is not an element of B. Alright, so I'm going to start with it where X is an element of A. I can just highlight all of that. So X is an element of A, all in here. Then X is not an element of B, so I need to erase anywhere where X is an element of B that's already been highlighted, well, in here it's an element of B, so those need to go away, right? So I'm left with just this part. So A minus B is just this part of A, is the part of A that's solely in A, not in B. That's the difference right there. That's all I have for today. Just a quick video to kind of get you guys thinking about these things. Hopefully you guys know these symbols. If you don't know them, hopefully you know them now, because they're really important. They show up again and again. Alright, so thanks for watching, and we'll do a lot more practice with set operations in a later video. Have a good one.